Okay, so let's begin on our final lecture. It's still definite integral, but this one is more into revolution. If you remember from your high school days, where we turn around the axis by 360. If you go it this way, the formula, it will look something like that. So it's just like instead of 2D, it become 3D. Okay, you can have it become like a cylinder like. And remember the formula here is y squared. Right? Yang one of the most important part lah, where people always keep on forgetting. If it revolves around the y-axis, I mean the other way around, then the formula becomes x squared. Okay, and of course, do not forget the pi as well, including the x-axis. Okay, so let's have a look on a few examples. Easy example first. So we give here the volume solid generated by revolving the region bounded by curve x squared plus 1. X-axis is bounded, okay? These things are bounded. X-axis. And the lines x1 and y2 through 360 about the x-axis. Okay, so one moment. Hopefully we got the graph. Yep, we will be revolving around there. So this area. So we go rotating around that one, 360, and y here. Everything is there. So how do we solve this one? The formula will be pi y squared equals to f dx. So your y squared is x squared plus 1 squared dx. Until here, you guys okay? This is simple first. Oh, what about the limit? It's 2 and 1. Because here, 2 and 1. So let's have a look. Okay, how should we integrate this one? Any suggestion? Integrate kurungan, I mean the bracket is not wrong if you want to do it this way. X squared plus 1 cube. Okay, Ahmad, you think this one right? I want you to look very carefully. Class can have your attention. This is the wrong answer. Because you have generated extra variable. So it's wrong. We don't want to generate an extra variable. Extra constant is fine, but extra variable is not. Okay, I can tell you even further. Normally, let's say something as simple as this. 2x is if I differentiate, I get myself 2x. X squared, sorry, if I differentiate, I get 2x. And if I integrate, I got myself back to x squared. Okay. So if you're saying that if we differentiate, we got here, are you sure? Sorry, the other way around. We integrate, we got here. Do you think if we differentiate, we get here back? Because if you here, it will be u over v, so it becomes a sort of a quotient rule, and it wouldn't get there. Okay, do you understand it, Ahmad? Oh, I did. Okay, so get apa? I mean, something so important. I don't mind explaining many times. So what's the best way to integrate? Yep. Tips, if it's simple, then expand. So you expand first, and then you integrate, and then you substitute. You guys okay? Okay, just asking, do you hear echo or engine sound? Okay, very good. Okay, example 2. Okay, so we got our self curve of y(x cubed), and it goes to the y, tracked by the y-axis, and the line of y1 and y8 through 360 about y-axis. Okay, so let's try imagine how it looks like. So x cubed looks something like this, and it's tracked by the y-axis. Y1 and y8, and this is 1, let's say this is 8, through 360, the x-axis, y-axis. So it's somewhere around here. So this one you can see it revolves the other way around. I mean, not x. So if we go to the y, so this the formula will be, remember this one, it means there's a pi outside. So it's going to be x squared dy or dx. Dy. Okay, but our formula here is x cubed. Now x squared. What should we do? Yep, so you change. How are you going to directly get x squared? I think I got your idea just now, but I think it makes more sense if you do it this way first. Firstly, we cube root that. So we got here 1 over 3, and here is 1. And then once you square, then it's not that difficult to see that this is y2 over 3. If you are talking about, then we split it up, such as this, y equals to x squared, but you bring one of the x come here. And you have both y and x, and you do not want that one. We just want y without the x. Are you okay? Or did I get your message right? Okay, so we can see the solution. Yeah, our graph is the same as the graph provided, and our working steps are the same. And how do we integrate this one? Just integrate normally, macam biasa, normally, and just substitute, and we get the answers. Are you guys okay? Very good. Okay, but now we are trying to go when there's a two curve. Okay, so we can see here two graphs. One is F, another one is Y, another one is F, another one is G. The way of how you solve them is, okay, let's say if we do for area first. How do we do for area? What's the formula if I want to find area for this one? Can someone answer that? If I just want, yeah, top minus bottom. Okay, and after this 9:20, I'm not accepting any more people coming. If we see this one, we do top minus bottom. And in this case, it's dx lah. This is for area. Now, if I'm upgrading it to volume, I mean with the rotation as well, within the x-axis, what's the difference of the formula? There'll be plus, can I have your attention? Here we apply here, and then use square. What I'm trying to say is, I've seen a lot of people doing it this way instead. Top minus bottom. And then instead of doing what I mentioned just now, they do it this way. They square the whole thing. The bottom one is wrong. The first one is correct. I mean, the second formula that I write down is wrong. The first formula I write is correct. So you need to square minus, then you integrate. So if I were to write down things again, so you square, and then you minus or simplify. And then only you integrate. Right. Sorry, this pen is not as good as my previous pen. So you see the formula there? Yes? Yes? No, it doesn't work that way. Yeah, that's what I'm trying to say as well. You cannot do. I forgot. But thank you for reminding me. So the wrong step is minus square. Sorry, integrate. And third one is square. I mean, I did this as well when I was still young lah. No, not so young. I think 20 plus. I still do this. Okay, if you do what like you mentioned just now, you find the area and then you square. No, it doesn't work. You need to restart the whole thing again because the square appears before the integration, not after the integration. If you see here, the square is inside the integration. You get the idea? Can you see why you're wrong? It's alright, man. I mean, making mistakes is good. It's a way to learn. And I make that mistake as well, so I totally understand, man. Okay, can I continue? Any confirmation? Okay, so for the y-axis, the formula is still the same. You need to figure out which one is top, which one is bottom. So the best way to know is that you need to switch your head. Don't gang your head. Flip your head. Or rotate your head. Okay, so in this case, it's still the same. This is, top minus bottom. Then yes, I just go through the slides. Okay, this is the top. This is the bottom. And remember, you need to square first. Square minus integrate. Okay, so let's try this question. Curve by this one and that one. Oh, now it has both sides. It has the x-axis and the other one has the y-axis. Okay, so let's begin. Let's see how the graph looks like. Okay, x cubed, and before 1, square root is faster. Yes, we make different color for 1. Before 1. After 1, the cube is faster. Because, let's say if I take 0.4, you will give, 0.4 square root will give me 0. Alright, I make calculator. This basically saying if I do 0.3 squared, 0.09, this very far smaller than if I try to square root. Okay, that's careless of me. I need to bring my calculator. I didn't bring it today. Right, so that's the graph. And it did, if you see this one, it doesn't say what is the limit. What I'm trying to say is it doesn't say to us what is the value for A and B. Okay, normally when if you want to integrate dx or dy for area, it will include you the value of A and B. But in this one, it's not given for the case of 2 curve. So how are we going to find the limit? Between what? I got your idea, don't worry, man. It's called intersection point. Okay, so we take these 2 equations. You can do simultaneous or just compare them. Because you see here y and y, right? So you can just directly write down such as the x square root equals to x cubed. We don't want the square root, we want the square root to just disappear, so we square both sides, 6, and then s6 minus x, 0. Class, remember, you cannot do this. That is wrong. You cannot simplify the x. If you want to find variable, you cannot simplify the x, but if it's a function, then you can simplify the x. That's something that I got quite recently. So x6 minus x equals to 0. So we can factorize one of the x. x5 minus 1, 0. So x is equals to 0, or if you go further down, x equals to 1 only. So here is 0, here is 1. You okay? Right? Yeah, that's the same. You can even go 1 here, substitute back here is 1, because we're going to do the y-axis as well. Careless of me. I think the intersection point is quite a normal exam question. Oh, sorry, I was a bit fast. So this is for defining the x-axis, x revolution. Just nothing much. So, like I mentioned just now, you squared first, and then you minus integrate. I mentioned. So you square, and you minus, simplify, and then only integrate. That's the process. 1, 2, 3. Then substitute, we get the answers. You guys fine? Yes. Am I too fast here? Hello? Okay. Now, what about if we try ourselves for y? For the y-axis, rotation through y-axis. Let's try ourselves. Rotation y-axis. Because I heard some of you are weak in this one, so let's try by ourselves. So we know the formula is y equals to square root x, and the other one is y equals to x cubed. So how do we do rotation through y-axis? So which one is top, which one is bottom? This one is the top, this one is bottom, based on the graph just now. The formula is x squared minus, this is x, what? Let's call this x1, x2. The dy or the x? Dy. Okay, what am I missing in the formula? Yep. In exams when I was around your age, I think until adult, sometimes I miss my pi. Okay, so x1. How should I find x1? Firstly, I need to square this one for me to find the y squared equals to x. So if I'm squaring it again, I get myself y4 equals to x squared. So here is y4. Are you guys following me? Come again? Nak saya ulang balik kah? Yes. Yeah, you are right. Just careless of me. Yes, you are right. In this case, this is the top. This is the bottom. Because we are approaching from the y-axis. Thank you. No, what? Never mind. Let's try the one that we did just now. Okay, so for this one here, firstly, if you look, the formula is x, right? Only x. So the x1 here. It's only x. So you need to square it first for you to get y squared equals to x, because you want to make the square root disappear. And then there's a square because of this square. So I get myself now y4 equals to x squared. Okay. So now only I can substitute inside here. So I get myself here as y4. Are you guys okay? So here's dy. Okay, so now for the x2, I need to wrap this one. Firstly, you don't want to have this square root. You don't have to have this cube. So you cube root everything. So you got yourself y 1 over 3 equals to x. And then you see there's a square over here. So you square both sides. So you get yourself y 2 over 3 equals to x squared. So this one you substitute inside there. So y 2 over 3. You guys okay? Very good. And then only you minus and then you integrate. Can you minus this one? You cannot, it's already as it is, and then you integrate it up. Okay, then what about the range? What about this value a and b? 1, 0, we have calculated this now already. So it's 1, 0, 1, 0. Right, so let me see the answers, the official answers. Yes. One moment. Okay, so let's see. Ta-da! You guys okay? Are we too fast? Okay kan, dah explain semua. Class, can I continue? Any? Okay. So that's the conclusion of it, nothing much. Okay, so I would like to go through with you some example, nothing much over here that we have covered most of them. Oh, there's one exercise. Sketch a region bounded by the curve 1 plus sine x and line x equals to 0. And we know is about 360 about the x-axis. There's only one curve. There's only one curve. And we are bounded by this. So this one, and we know it's rotating around the x-axis. And sine x graph, if a sine x graph is like this, if a 1 plus sine x, we go by 1, so it becomes like this. That's how the graph looks like. With the maximum as 2, minimum as 0. X equals to 0. This one is here. X equals to pi over 2. I guess is here. And let's choose a different color for this one. Y equals to 0. I want to use this. It's here. Y equals to 0. So the region bounded is here. How do you solve that? So you should integrate what? Since x-axis, right? So here is the x, and don't forget there's a pi up there. What should we integrate inside? We are supposed to do, normally the integration is y, right? So here's the whole y, and don't forget there's a square there. So it's going to be 1 plus sine x. You guys okay? And how should we integrate from here? Should we use bracket rule? Can someone tell me why we should not use bracket rule? Exactly. If you use bracket rule in this case, you get yourself 1 plus sine x over 3 over 3. The problems comes down here. When you differentiate inside, you got yourself cos x. This is extra variable. You don't want to create extra variable. So this one is wrong. Be careful, even I make the mistakes. So how should we integrate this one? You should expand it. 1 plus 2 sine x plus sine squared x. How should you integrate sine squared? Any suggestion? IBP you only use when there are two types of equations, like x meeting with sine x squared, like x mixed with trigo. In here, this is sine squared, so you should not use IBP. Can you integrate sine squared directly? Can I get myself sine cube x over 3? And that's wrong. To be more exact, if you do it, it becomes cos over here, and you have created an extra variable. Oh, it seems you forgot. You need to use the double angle formula. 1 cos 2x over 2. And of course, you can split it over 2 over 2. And this one here can interact with this. You can simplify it out for you to get yourself as 3 over 2. Okay, so let's have a look on the official works. What we have discussed, yeah, v squared 8. And then the sine squared becomes that. And then you see here, this one and this 1 over 2. They can interact. To be more exact, this one here, they split first. So this one becomes 1 over 2 and this one interact. So they get 3 over 2. And then from here, then you integrate. Integrate 3 over 2. 3 over 2x. Integrate sine 2 sine x. Well, negative 2 cos x. Integrate the other one. Can you try? What do you think? Still easy, not that difficult. Differentiate what you get cos. Sine 2x. And then you need to differentiate inside. Put it down there. 2, and then don't forget the original 2. And then they become 4. The minus still there. Okay, then substitute the limit. I was wondering why I didn't write this one down. Because this one is equals to what? 2 cos 0 equals to what, class? Yep. Yeah, the works quite simplify quite quick. Okay, sorry about it. Okay, we want to find here the R, and we want to find the area region of R, and it's revolve the 360 about the x-axis. Okay, my question to you is, which way is it easier to do? Is it easier to do in this direction? I mean here. Or is it easier to do in down direction, in the x direction? X or y? Dx or dy? If you look at the equation, y over 3 over x, and the other one is y plus x equals to 4. Why dx? The, the correct answer is actually dx is the only way, because it says here 360 about the x-axis. Because the results, the final results will be like this. If you do the y way, you get here, the volumes are completely different. Okay, so hope you know why is dx. It's a trick question actually. When I look at this, I was like, oh, I can do through that, I can do through here. But when I read the question carefully, oh no, I can't. Dx is the only way. Hope you understand it. Alright, good. Okay, so if dx is the only way, and I let me rewrite things again. I mean it's a bit small there. My bad. So y equals to 3 over x. That one is not a problem. The other one is y equals to x. Sorry. Some people might argue, so any y equals to x. This one is y plus x minus 4. Y plus x equals to 4. So how do we find x? Well, simply y equals to minus x plus 4. And you got it. If I want to find the area, we do top minus bottom. So it's negative x plus 4 minus 3 over x dx. Sorry, negative x plus 4. That's what looks more like a y. My bad. My handwriting. This should be good. How do you find the limit? Well, actually B dia nak area dulu. But you're not wrong. I'm moving there. And it's my bad for not telling you I want to find the area first. Let's say if you want to find the area. Okay, how do you find the limit? Cik persilangan lah. Yeah. Or intersection point. Same thing. See here, this y. See here, there's also y. So you can compare them, equalize them. So I get myself 3 over x equals to negative x squared. No, sorry, too fast. Negative x plus 4. You don't want to have the, See this x, you don't like it. Multiply. 3 equals to negative x squared plus 4x. X squared minus 4x plus 3. So x is equals to if I'm not mistaken. So 1 and 3. If you're trying to solve the first part of A, they ask for the coordinates of P and Q. Then you need to be careful. You need to find it out. So the coordinate. Just to substitute the value of y. So just now I think the easiest one y equals to x. Sorry. There are many ways on how to find it. Doesn't matter. Y equals to negative x plus 4. I think this is easier. So y is 1 and 3. If 1 is 3, if 3 is 1, so 1, 3, 3, 1, that will be the coordinate. Or in this case here, it will be just 1, 1 and 3. Alright, this is for area. What about for volume? What's the difference of this formula and for area and for volume? Class, can I have a suggestion? What should I do for volume? I should have pi outside and then square. Remember, you need to square minus integrate, not minus integrate square. The correct way of doing is square minus integrate, not the other way around. For like, if you do square integrate, sorry, minus integrate square, and this one is wrong. Okay, I stop it there. I guess that's more than enough. If you would like to try it out, it's question number 31 past year. For viewers, if you want to try it unto yourself, let's write down a bit here. The answer for the question will be B is 4 minus 3 ln 2. For the C is, oh my goodness, 8 over 3 pi. Okay, I think that's all for today, and that's the wrap up for integration. I hope things are okay with you. Alright, anyway, for viewers, thank you for watching. Please comment, share, and subscribe. And for my students, thank you for coming. And yeah, I'll see you again next time on the next class. Okay, that's all. Thank you.